Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will continue with CSAT previous year questions. We have been looking at CSAT QA 2023 series, and this is part 3 of this series. So, without wasting any time, let's look at the first problem of the day. So, the first question is if ABC and DEF are both 3-digit numbers, such that A, B, C, D, E, and F are distinct non-zero digits, such that ABC plus DEF is equal to 1111, then what is the value of sum of all the digits from A to F? Well, it's pretty simple. What we have to do is we have to divide this number 1111 by 9 and get the remainder. So when I divide 1111 by 9, the remainder is going to be what sum of the digits is going to give me, which is 1 plus 1 plus 1 plus 1, which is 4. Well, the sum of the digits, the numbers that they're going to form, which results in 1111, they will also give us the remainder 4. So out of the 4 options, if we take 31 and if we divide it by 9, which is like saying add the digits, this also gives us 4. Or in other words, we can say when we divide 31 by 9, we get the remainder as 4 also. None of the other 3 options give us the remainder 4. So D becomes our answer. Second problem. D is a 3-digit number such that the ratio of the number to the sum of its digits is least. What is the difference between the digit at the hundreds place and the digits at the units place? So the number that we can take is 100 when we divide it by the sum of the digits, which is 1 plus 0, which is going to give us 100. If you take the largest 3-digit number, it's going to be 999. If you divide it by 9 plus 9 plus 9, this is going to be 999 by 27, which is 111 by 3, which will give us 37. So we drop down. Now, instead of 999, if I write 111, it will still give me 37. If I write 888, it will still give me 37. So is there some way by which we can decrease it? Basically, we have to make the numerator as small as possible. For that, the leftmost digit, instead of 9, we should make it as low as possible. What is the lowest digit we can make? We can make it as 1. So 199 divided by 1 plus 9 plus 9. So this is 199 divided by 19, which is going to be very close to 10.5. Now, instead of 1, if I take a 2, what happens is numerator increases by 100, but denominator only increases by 1. So it will not give us a larger one. So this is the number wherein the difference of the digits gives us 8. Straightforward. Now, you must be thinking that what about other numbers? You can give it a try and you will realize that numerator increases drastically. Your denominator doesn't increase by that much. Next problem. 2 raised to 192 is divided by 6. So 2 raised to 192 when divided by 6, we can write 2 into 3. Now, if there is anything common when you are trying to find out the remainder in such case, take it outside and then calculate with whatever we are left with in the dividend and divisor. Now, the thing is, 2 to the power 1 when divided by 3, we get the remainder as 2. 2 square divided by 3, which is 4 divided by 3, gives us a remainder of 1. 2 cube, which is 8, when divided by 3, it again gives us a remainder 2. 2 to the power 4, which is 16, when divided by 3, it again gives us a remainder of 1. So we see the pattern that is either 2 or it's going to be 1. When do we get the remainder as 2? When the power is odd. When do we get 1? When the power is even. Since the power is odd here, we will get the remainder from here as 2. So our final remainder is going to be 4. So option D. Next, In an exam, the maximum marks for each of the four papers, namely PQR and SR 100, marks scored by the students are in integers. A student can score 99% in n different ways. What is the value of n? So 99% in n different ways is like saying 99% of 100 marks of paper P, 100 of Q, 100 of R, and 100 of S, which is basically saying 99% of 400, which is going to be 396. Now, one out of these papers, which one is going to get what marks? We will look at the arrangement later. So the first possibility is we will give the highest marks to three papers and the leftover to the next one. How many ways can this happen? Because this 96 can go to either P or Q or R or S. So what we do is we take the factorial of all the numbers that we see, divided by the number of times every number occurs. 100 is 3 times. So we'll divide it by 3 factorial. 96 is 1 time. So divided by 1 factorial. So this will result in 4. Next is, what if we change the second 100 and decrease it by 1 and increase the other one by 1? Because we need to keep the sum as 396 constant. This is going to be 4 factorial. 100 is written 2 times, 99 is written once, 97 is written once. So this is going to give us 12. Next, what if we write 99 as 98, decrease it by 1, and 97 will increase by 1 and give us 98. Total ways are going to be 4 factorial. 100 is written 2 times, 98 is written 2 times, so this is going to be 6. Now, if I change the next 98 to be 97, it will repeat. It will be the same as the previous case. So the next case is we will change this 100 to 99, the next one to be 99, and then the next one is going to be 98. This is going to be 4 factorial. 100 is 1 times, 99 is 2, 98 is 1. So this will give us another 12. Next, if we try to decrease 99 by any further, it will make it lesser, right? It will be repetition of the previous one, basically. So the next is change this 100 to 99, as in, what if a student gets 99 each of the 4 subjects, thereby increasing, thereby getting 99 percentile overall. So this is going to be 4 factorial. 99 is repeated 4 times, so it's going to be 1. Total is 4 plus 6, that's 10. 12 plus 12 is 24. 10 plus 24 is 34 plus 1, 35. And anyways, once we have reached up to here, we know that we have crossed the largest value that we see is 23. So it's pretty sure that we'll have more than that. Next, a flag has to be designed with 4 horizontal strips using some or all of the colors, red, green, and yellow. What is the number of different ways in which this can be done so that no 2 adjacent stripes have the same color? So let's say this is the flag and it has got 4 horizontal stripes. So 1, 2, 3, 4. Now this could be either red or blue or green. So there are 3 ways. Now the next one, if I have taken a red, I can't take red again. So I'll have to take blue or green in the next one. Or if blue was taken as the topmost stripe, I can't take it in the next stripe. So it's going to be red or green. So there are going to be 2 ways. And whichever color I have taken here, suppose I had taken red here, and from blue and green I have taken green here. Now red can come back again and will have an option with blue. What if I take red again? So that's another 2 possibilities. Now green can come again and may have again 2 cases. Since all the stripes have to be colored or filled with this, so we will have to use and in PNC means multiplication. So this is 8 into 3, 24 ways. Next, A rectangular floor measures 4 meters in length and 2.2 meters in breadth. Tiles of size 140 centimeter by 60 centimeter have to be laid such that the tiles do not overlap. A tile can be placed in any orientation as long as its edges are parallel to the edges of the floor. What is the maximum number of tiles that can be accommodated on the floor? So we have this floor whose length, let's write that in centimeters. So this is 400 centimeter and this one is 220 centimeter. Now we have to place tiles here, the tile size being 140 and 60. So our target is to make 220 by adding any number of combinations of 140 and 60. So 140 plus 140 will cross 220. 140 plus 60 is within 220. 60 plus 60 plus 60 is going to cross 220. No, 60 plus 60 plus 60 will give us a total of 180. But then 40 centimeter will be left. Can we use it? So if I lay down 60, 60, 60, K3, 140 we will have, and then 400 that we can only go up to 2. That will be a very less number of tiles. Okay, so how about let's look at 400 now. Can we make 400 using 140 and 60 any number of combinations? Well, if we take 140 and 60, so that's 200, and another 140, 60, that's again 200. Okay, so 140 it's going to be somewhat like this, right? And this is 60. The next one is 60 and 140. So it's going to be something like this. The next one is again 140. And then we will again have 60. Okay. So this is 60, this is 140, that's 200. This is 60, 140, that's another 200. So we can place 2 more here. Now, this is 140 and 60 plus 60. So this is 60 and this is 60. So basically what happens is this is thinner than expected, right? Because this entire length is 140 and this is 120 only. Now 140 plus another 140 we can't do. So 6 we have so far figured out. 60K, how many more can we place here? Can we place another 60 here? 60 and 140. So this is 120. We can only have 100. What if we place another 60 here and we place another 60 here? So this is going to be 60. This is going to be 60. So that is 8 as of now. So this is 180. So this is only 40 left. Well, this is entire 400. This is 140. And this is 80 left. So we will have to come up. The 40, the width is not good enough. Okay, so 40 looks to be greater than 60, so it might be a little confusing. So what we can do is we can make it lesser. So this is mere 40, right? So I can't put any brick there. This is 140, so 220 minus 140 is 80. So I can't place any brick there. If I place 60, then 140 is the length required. I cannot do that. So this is overall 8. Why does it feel like we can adjust 9? 120 and then we need 100. Okay. How about I place 60, 60, 60. So that would be 6. And 140 would be there. Okay. We can try that. That will place 60, 60 karke as many as we can, which is going to be obviously only 6 of them because that's 360. So out of 220, it's going to be 140 here. So we will have 1, 2, 3, 4, 5, 6. And let's say this is less. Let's say it's this. So this is 60 each. And then this is 40. So I cannot put anything there. And since this is 140 out of 220, we are left with 80. Now that 80, we can place 60 here. And then that is going to be 140. Right? So this is 60 and this is 140. We can place another 140, so that's 280. 280 plus 140 will cross 400, so I cannot place the third tile here. So this is also going to give us an 8. We have to accommodate as many as possible. We can see that this is a total of 8. There is a lot of space remaining. So we'll have to, there is definitely going to be one particular tile that we can place. Okay. Let's restart. Let's think about it. So this is 220 centimeter and this is 400 centimeter. Now 400, what we can do is if we break down into 60s, that's going to be 6 alone. So the very first solution that we were looking at. So this is going to be 1, 2, 3, 4, 5, 6. And out of 220, we can have a total of 140, which is going to be more than half. So this is one brick. This is the second one. So we will have 6 such bricks that we can lay down, right? Okay. Now, when this is done, what happens is this is going to be 140, while each one of them is going to be 60 long. So that is going to be 360. So only 40 left. Now, in this one, we have got 80 left. If 80 is left, we can definitely lay down the tiles horizontally within the 60. So that will need 140 somewhere up to here. And 140 plus 140 is going to be 280, which is little less than 300. So this is 300. So we have got 2 more tiles here. Now, this is 140, this is 140. Now the thing is, if I happen to somehow place one more tile horizontally of length 140, it will cross 400. So we can't do that. So this is 60. Now, what if I start putting the tiles from the bottom but vertically? But for that, I will have to get rid of this particular 60. If I do that, this is only 100. What if I get rid of this one as well? So we have got 4 plus 2, 6. Now, the leftover we have is this is 280. So this is going to be a total of 120. Now, 120, what we can do is we can complete this by taking 60 and 60. Now, once this is done, this is going to be 140. So the leftover, this is going to be 220 minus 140, which is 80. So 80 is left, and this is more than 140, and this is more than 60. So basically, we can place 140 by 60 ka ek lone tile like this. So we will have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So a very tricky puzzle, very tricky problem. If there was not enough space left or enough space wasted, most likely I would have settled with option C, which was 8 tiles. But since I can see that there was a lot of space left, a little rearrangement may give us another tile, additional tile. So that was forcing me to, solve it again and again. So third time is a charm. So we got the answer. Thankfully, we do not have an option which is more than 9. So we will be at peace now. Let's look at the next problem. There are 5 people P, Q, R, S, and T, each of whom has to be assigned one task. Neither P nor Q can be assigned task 1. Task 2 must be assigned to either R or S. In how many ways can the assignment be done? So if we look at task 1, task 2, task 3, task 4, and task 5. So we will start with the condition which tells us कि ये होना चाहिए. This is supposed to happen. So task 2 must be assigned to R or S. So if I write down P, Q, R, S, and T, T2 has 2 options. It's going to be R or S. Okay, we'll start from this. Suppose R is used here. Now we will go to the next condition. It says neither P nor Q. Thankfully, there is no common people between these two. Otherwise, it would have made the question more complicated. So now let's look at the next condition. Neither P nor Q can be assigned task 1. So in task 1, if we can't take P or Q, and one among R or S, they are already here. So there are only 2 people left, S and T. So if R is used here, we will say that S or T will come here. Or if S was used in task 2, we would have said R or T can come there. So that's another 2 options. Suppose here we have utilized S. Task 3, we have all 3 available now. So that's going to be 3 options. Task 4, we will have remaining 2. Task 5, we will have remaining 1. So all the tasks are mandatory to complete. So we will put AND, which is multiplication. So this is 8 into 3, 24 tasks overall. Sorry, 24 ways overall to complete these 5 tasks. Okay. Next one, data sufficiency. Is P greater than Q? First statement says P into Q is greater than 0. So P into Q is greater than 0. So P and Q, they both can be positive. P and Q, they both can be negative. Which one is larger, which one is smaller, we have no idea. तो पहले ऑप्शन से तो बिल्कुल ही नहीं होगा. ठीक है, so B option cannot be our answer. P square is greater than Q square. If P square is greater than Q square, then P may be positive, Q may be negative, P may be negative, Q may be positive, P and Q, they both may be positive, P and Q, they both may be negative. कुछ भी हो सकता है, right? So from second statement alone also will not get the answer. So A is also wrong. Now we will have to club them. If we club them, we will only consider the cases where it is true for both. Now, PQ, they both are going to be 0. PQ, they both can be less than 0. So let's look at the cases. P square is greater than Q square. Let's take the positive wala case, right? So P is going to be 3 and Q is going to be 2. So is P greater than Q? Yes, it is. Let's look at negative वाला case. Negative ऐसा होना चाहिए कि P square is greater than Q square. So P is going to be -3 and Q is going to be -2 such that their product is negative, is positive, right? It's still greater than 0. And P square is going to be greater than Q square. But is P greater than Q here? No, it's not. Still confused. So the question cannot be answered by using both these statements together, Habibi. So D option becomes our answer, right? Question number 9. Is P plus Q minus R greater than P minus Q plus R, where P, Q and R are integers, positive, negative, 0, everything is allowed, right? So question asked is P plus Q minus R greater than P minus Q plus R? So what we will see from here is P gets cancelled out. So we will have Q is greater than R, 2Q greater than 2R, remove 2. So question is basically asking us, क्या Q R से बड़ा है? If I look at the first statement, it says P minus Q is positive. How is that related to R? Can't answer. So B statement is no. Next, P minus R is negative. So how do we know this? Q is missing here. So this gets eliminated. So option A nahi ho sakta. Now we will go ahead and club them. If you go ahead and club them, please understand that on the number line, anything that you write to the right of something, it has to be a larger value, right? Doesn't matter whether we are dealing with negative, positive combo, negative, negative combo, positive, positive, doesn't matter. On a number line, anything that is written on the right hand side, anything that is written on the left hand side, the right hand side is going to be greater. So when we read P minus Q is positive, so if Q is here, P has to be to the right of it. So P minus Q positive होएगा ही नहीं. P has to be greater than Q so that P minus Q is positive, isn't it? Second statement, P minus R is negative. If P minus R is negative, which means P is smaller than R. Negative, positive, don't worry about it. P R से छोटा है, which means P is to the left of R. We can say R is to the right of P, for sure. Which tells us that R has to be greater than Q. So the question asked is Q greater than R? The answer is no, it's not. Since we are able to still answer the question, which is a definite no, we can mark option C, that the question can be answered by using both the statements together, but cannot be answered using either statement alone. Right? So a very good question, and it's better than visualizing the values on the number line rather than case taking all the values positive, negative, 0 सब लेकर सॉल्व करने का कोई सेंस नहीं बनता इधर. Well, if you guys have any question, please go ahead and ask. If you see any problem that you are facing, ask it in the comment section. We will definitely reply to that. Okay. So thank you, everyone. Thank you for watching. Please make sure that you subscribe to the channel if you haven't yet. Like the video and share it with your friends. Until next session, take care. Bye-bye.